of it all. I think of you sometimes. I'm gonna spend some time with you. Just the two of us. Can't make it if we try. Just the two of us. You and I. All right. I don't hear my own voice. I just like to sing. All right. So let's see. We're good there. We pause that. Let's do this thing. Let's hit done. Share screen. That's good. We can make it. All right. That looks good. And we're gonna hop over here. Okay. So this presentation is kind of a repeat of what I did with my students earlier. Obviously, you guys weren't there, but there is a recording of what we talked about, but I'm just going to do it live now. Let me see if there are any. The main things as far as announcements, we are rapidly approaching the end. I think the main thing that you all need to be aware of is that we are rapidly approaching that hard deadline, right? So after the spring break, basically we have like 3 weeks of lecture and then 1 week of exam and then one more lecture. And then a couple of weeks before the exam, right? So we have those 3 weeks of lecture. This is week 2 of those 3 weeks before exam 3. The hard deadline for all assignments on Pearson is a May 1st, which is a Sunday night going into Monday morning at midnight, 11:59 on the Sunday night. That's at the top of the week of finals. So what that means is that when the clock hits 11:59 p.m., going from Sunday to Monday, everything on Pearson is going to lock out. And the only thing that you're going to have access to is the final exam, right? So I say that, to say that you want to go ahead and get your items in Pearson in order. One student had a question earlier about the grading on Pearson. The whole point was that there's an order of priority, right? I think he asked something about the homework and like, does he have to redo everything or just specific questions? When it comes to the homework, I think you can do specific questions. We got a little visitor today. Can you please go back out? What is that? It's something that does not need to be in here. With the homework, you can do specific questions and it'll boost your overall score. But then with the quizzes and exams, you have to redo the whole assignment to boost your score. So that's why I kind of do things the way that I do it. Because like with the exam, for instance, so the order of priority, you want to prioritize the exams first. Like if you don't go back and do anything, you definitely want to make sure that your exam scores are where you want them to be. You can still earn up to 90% on any assignment up until May 1st. Because I think the exams overall count for about like 80% of your overall grade. I'm sorry, I'm totally distracted. Got a visitor. I have the door open. So I got a little visitor in here and I'm trying to think about how to get him out. But yeah, exams are going to be about 80% of our overall grade. And then, I can get him out now. Okay, give me a moment. I'm going to try to get him out. It's going to take some finagling now. Oh, no, okay. This way. Oh, he may have gone. He may have gone. I had to use some Nickelodeon Avatar wind bending to get him out. I just swiped the air and he went with the wind. And I think he went towards the door and I think he went out. I got the lights out, so he should be going towards the light as well. Oh, he's still here. God damn it. Okay. But yeah, so the exams are 80% of your overall grade. So you definitely want to put those in order first. You want to prioritize those. Then after the exams, you would prioritize the quizzes, but the quizzes are only 10% of your grade, but they're only like 5 questions each, right? So I intentionally tried to make those short just to give you a preview, a precursor to kind of prime you for the exams. The homework is a lot of work for a little bit of points. The real intent of the homework is really just to prepare you for the exams, right? So I don't want you to put too much energy in trying to make up that work. You want to put more of your energy into getting your exams in order. That's the bulk of your grade. That's the most amount of points with the least amount of work, efficiency, right? So there's that. I think that's the bulk of it. We have right at about 5 weeks remaining, like the entire month of April. Once we hit the end of April, that's it. Then we got the first week of May or finals, and graduation for some people and things of that nature. As always, if you have questions, comments, or concerns, feel free to unmute yourself to get my attention and we can talk about anything that you like. And again, just as a reminder, this is remote asynchronous, so you're not obligated to stay, but my intent is to use class time as like a Q&A. And I just fill it with the lecture because oftentimes I found it difficult to get students to ask questions. Again, you're not obligated to ask questions, so I just fill it with like the lecture and homework and things of that nature. Also, I do kind of want to try, I'm still open to like the last 4 lectures. Like I checked the schedule earlier today, and in the schedule, I have those blocked off for like final exam review, which is what I still want to do. But I definitely want to take one of those lectures and I want to see, can we like take some of the stuff that we've been talking about and apply it to something that we like, right? Something that's relevant to us. Like for me, for instance, something that's relevant to me is like, I'm a gamer. If you watch the stream from this morning, the last 10 minutes of class, like, you know, the timing was there. We did everything we needed to do. So I went on and did a quick 10-minute match, you know, so you can see some of my gaming. But I want to see, can we take some of these concepts and apply them to something that's relevant to us? Also, I was considering like origami. I do origami, so that's like measuring. And one time I applied it, I made a custom design where I took something that existed, but I augmented it so it could fit a certain shape. I did measurements and did some calculations and tested it out, and it actually worked. I was surprised. So, and then like another like application, I don't have a 3D printer yet, but you know, honestly, any kind of like 3D object that you want to make, you can make it with a 3D printer, apparently. Like anything that's in the physical reality, you can make it. You can even get a 3D printer and print other 3D printers. And like you can build 3D printers for friends. It's like bizarre. Like it's so interesting. It's like basically a modern Lego, right? Lego or Connects or whatever. I grew up on Connects, but yeah. So anyway, that's a little bit of backstory. So again, as usual, if you have questions, comments, or concerns, feel free to unmute yourself to get my attention. Otherwise, what we're going to do, we're going to go ahead and just look at the lecture for today. So I think last time we did section 6.1. So then today, I'd like to work on section, continuing chapter 6, further topics in algebra, and we'd like to look at section 6.2, arithmetic sequences and partial sums. Let me check something. So with section 6.2, a few objectives, we'd like to identify an arithmetic sequence and find its common difference. Also, we'd like to find the sum of the first n terms of an arithmetic sequence. So we have a definition of an arithmetic sequence. This sequence A1, A2, A3, A4, up to AN and beyond is an arithmetic sequence or an arithmetic progression if there's a number D such that each term in the sequence except the first is obtained from the preceding term by adding D to it. The number D is called the common difference of the arithmetic sequence. And we have that the common difference is going to be the AN plus first term minus the ANth term, as long as N is greater than or equal to 1, right? So basically the idea here with arithmetic sequences, these are sequences where you have an initial term, which you call A1, and then the subsequent terms, basically you add a common difference, a common number to the previous to get the next term, right? So this is like one type of sequence that we can explore. So here we're asked to find the common difference of each arithmetic sequence. So again, to find the common difference, we just take, like for instance, it said the AN plus 1 minus ANth term. So for instance, like if we said 23 minus 3, notice that that one is what? 20, right? That's the difference there. And then, so if we take the third term minus the second term, so then that could be like 43 minus 23, that's also 20, right? So for part A, it looks like the common difference is 20. We're given an initial term of 3, and then basically we're just adding 20 each time. So plus 20, plus 20, so on and so on, right? So it looks like our common difference is 20. So hopefully, this is just kind of a random thing. Hopefully this experience has been okay for you. I know it's a bit unorthodox, and I know that like math generally creates a lot of anxiety in people. So, but I tried to set it up in a way to kind of mitigate or help you to face that thing and remove some of that anxiety. You know, like I intentionally kind of set it up so that you can have plenty of time and space to get what you need done and learn something and then keep it moving. You know what I mean? It don't have to be so, this thing. You get what you want out of the experience and what you need. It don't have to be one way or another. Just as long as you can kind of hold your own on some level. You know what I mean? So hopefully this was okay for everybody. For as many people as I could make it to be. Let's see the common difference here, right? So if we take, like, for instance, the second term minus the first term. So if we said 19 minus 29, that common difference is -10. If we said the third minus the second, so if we said 9 minus 19, again, the common difference is still -10, so on and so on. So for this one, it looks like the common difference is -10. Let's copy, paste. I'm pretty sure there's some gesture to paste. That seemed like it did. Okay, is there a way to redo? Oh, wow, just learned something new. How can I see the gestures? That would be, what's the info? No. Oh. This is more detailed than I want to get into right now. I know where it is, but I don't want to exit out of this just yet. I'll check it later. Okay, so these look good. 20 for the first one and 10 for the second one, and then we have our prepared notes or the type notes. So the common difference is 20. See, if you say 43 minus 23, any of these, the difference is 20. Then the common difference here was -10. Let me check, what time is it? Yeah, let me check Zoom one more time. So if we got any stragglers, we do have a couple of stragglers. So let me get these guys. It's fine for now. Man, you might have to hop back to where we left off. Okay. All right. So welcome, gentlemen. If you're just joining us, these sessions are recorded, and I'm pretty much doing the same thing I did with my students. So you can either watch this presentation or watch the one from this morning, where I'm kind of doing the same thing. There are a few Easter eggs. You might want to check out like the last 10 minutes of the morning session from today. I just did a little showcase of like some gaming. And honestly, when we started this one, I was singing. So if you want to singing anyway, I don't know. I don't really like to hear my voice sing, to hear myself singing, but I like to sing. So it is what it is. All right, so then we have this recursive definition of an arithmetic sequence. An arithmetic sequence, A1, A2, A3, 4 to AN and beyond, this means just continue the pattern, can be defined recursively, right? So the recursive formula, the AN plus first term is going to be the ANth term plus some common difference, where N is greater than or equal to 1. Again, this defines an arithmetic sequence where the first term is A1 and the common difference is D. Okay, so what we're doing here, this is section 6.2 on arithmetic sequences and partial sums. And this is one type of sequence where we start with one number and then we're just adding the same thing to the preceding term to get the next term. So if a sequence A1, A2, A3 is an arithmetic sequence, then the nth term, AN, is given by this, right? So we're going to have the first term plus N minus 1 times D. For instance, whatever the first term is, it is what it is. And then if we're adding the same thing, the common difference each time, say we want to get to the fourth term, right? So we start with the first term, and then we add that common difference D, we add it 3 more times, right? So then that's where we would say 4 minus 1 to give us 3 times D, 3D. Where A1 is the first term and D is the common difference, right? So this is how we can generalize the nth term for an arithmetic sequence. And as always, also, if you're just joining us, if anything is not clear, or if I need to stop or go back, feel free to unmute yourself and to get my attention and we can talk about it, okay? Let's go to the next one. So find the common difference D in the nth term of nth term an of an arithmetic sequence whose fifth term is 15 and whose 20th term is 45. Okay. So let's write what the nth term, the generalization for an arithmetic sequence. So we said the nth term for an arithmetic sequence is going to be the first term plus n minus 1 times the common difference. Okay. So then they essentially gave us an ordered pair, right? We were given what? When n is 5, the output is what, 15? And then when n is 20, the output was 45. So let's plug these two pieces of information. So this is like our n and our n. Our n and our n. Let's plug these into, let's just style like this. And I'm going to change this to this color. So let's plug these pieces of information in. So it says we're asked to find a common difference and the nth term, right? So let's see. So our A1, we don't know A1, so we're just going to bring that down. So let's do the second order pair first. So when n is 20, so if n is 20, we're going to have 20 minus 1, and we're trying to solve for a d, and the output should be 45. Okay. And then if we take the other piece of information, we're solving for A1. Now n is what? 5 minus 1. We're solving for the common difference, and the output should be 15. So since we have two unknowns, we needed two equations. That's why they gave us two pieces of information. It's such a beautiful day. Like, it's raining. I can see the sky a little bit, so it just has this calm, peaceful rain illusion, right? So if we keep going, let's simplify these. 20 minus 1 is 19, so we have A1 plus 19D equals 45. And then A1 plus 40 equals 15. All right. So then from college algebra 1, this is a system of equations of two variables. So we can subtract. We can say the first equation minus the second equation. So we can distribute a negative. All right. We're basically saying the first equation minus the second. Okay. When we do this, we get, so the first terms cancel. A number minus itself adds 0. 19 minus 4 is 15D equals what, 30. Divide both sides by 15. It looks like the common difference is 2. So then we can take this and plug it into either equation to solve for A1. So I'm going to plug it into the second one. A1 plus, let's do 4 times 2 should equal 15. So then A1 equals 15 minus 8, which is 7. So then the nth term for this arithmetic sequence should be 7 plus n minus 1 times 2. Right? And we can check this. At least we can check it against the information that was given. Right. So for instance, if n is 5, the output should be 15. So then 5 minus 1 is 4. 4 times 2 is 8. 8 plus 7 is 15. Okay. And then when n is 20, the output should be 45. 20 minus 1 is 19. 19 times 2 is 38. 38 times 7 is 210 plus 210. Wait a minute. Why am I multiplying that? Let's back up. Moving a little bit too quick, right? 20 minus 1 is 19 times 2 is 38 plus 7 is 45, right? And we got our desired result. Okay, let me check Zoom really quickly. Participants look good, and I think the chat is clear. Okay, let's keep going. Okay. So then find the common difference D in the nth term. Okay, so this is what we were just doing, right? So we got the two equations based on the two pieces of information. So then we were solving for A, 1, and D. So we had a system of equations. And then they just did that off to the side. They didn't show, it looks like they didn't show how they solved the system of equations. So we worked it. Another technique we could have used was substitution, where we solve for one variable, probably like A1, and then plug that into the other. But what we did was fine. Oh, I keep forgetting to simplify, right? I think we stopped here, but then we can distribute this 2 and simplify it down. We can get it all the way down to 2n plus 5, right? So we could have gone a little bit further. Okay. So then we have the sum of n terms of an arithmetic sequence. So let A1, A2, A3 up to AN be the first n terms of an arithmetic sequence with common difference D. Then the sum, I think it was 2 times. Oh, I remember. So earlier I was trying to remember how to derive this formula, and I'm now thinking about it, I think there was a little trick. I'm tempted to explore it. Hopefully I won't lose you guys. So let's kind of get to this first, and then I'm gonna see if I'm gonna try something real quick to see if I can derive this. So let A1, A2, A3 up to AN be the first n terms of an arithmetic sequence with common difference D. Then the sum Sn of these n terms is given by this guy here, where AN is A1 plus n minus 1 times D. So like if we were to add up the first n terms, it would add up to this, right? So let me see if I can derive this really quickly. I'll give myself like maybe 5 minutes, right? So let's consider let's consider one sum of terms, right? And say, let me think, how can we do this? Okay. So the sum of the first n terms, right? That would be A1 plus A2 plus A3 up to AN, right? N of those terms. So then I think that, now what if we took this sum and added it to itself, right? We said Sn plus Sn. We added it to itself. So I'm going to say plus another Sn. I'm going to add it to itself, right? So that means, and Sn is still A1 plus A2 plus A3. I think this, let me see if this works. Okay. So if we take this, this partial sum, right? If we take this and add these two equations together, if we add these together, on the left, we're going to have 2 Sn, and then on the right, does this help us? No, there's something else. Let me think. There's something here, but I just can't remember how to do it. I got to think about it somewhere. I'm going to let this go for now. It's some kind of play like this. You might have to like some other kind of trick where you might have to multiply. Because if you add those together, you're going to get the 2 out in front. You need some terms to cancel. I had to research that. I had to think about that. I can't think about it. I had to think about it because I don't immediately know what's top of my head. I got to think about it because I know I've seen it and I know how to do it. I just can't remember right now. It's fine. And for our purposes, we don't need to know where this comes from. And if anybody really wants to know, we can take some time and figure out where this comes from because I know it's right there. I'm missing something. Oh, does that do it? The first plus the last. Okay. So, yeah, I'm still trying to play with it. Okay. Again, for our purposes, we don't have to know where this comes from. We're just going to use this for right now. This is the nth partial sum. Again, if anybody really wants to know, and they want to know where this comes from, we can take some time and we can get to the bottom of where that comes from. It always helps if you're able to derive like these formulas and know where they come from, then it helps. But it's not always necessary. Where AN is, this is basically what we said from before. Okay, so we're just going to use this for now. Again, if anybody wants to see where that comes from, we can talk about it, and I'm sure we can get to the bottom of that. So now here, we're actually finding some of the arithmetic sequence of numbers, right? So we want to find the sum. So now here, let's just use what we just discussed. So the sum of the first n terms, let me see. We know we had A1 plus AN over 2 times n. That occurs n times. The first plus the last. Oh, okay, wait a minute. So if you reverse the order, that's the first plus the last. A2 plus AN minus 1. Okay, I think I see it. Okay, I'm gonna try again. I think I see it. So here, let's do this. I'm still stuck on the last thing. Let's try one more time. This is just a side note. As a matter of fact, let's do this. Let's just add a page, right? I think I can derive it. I think I remember now. So I was like, it's on the tip of my tongue. It was irking me. So now, say we have the sum of the first n terms, right? That's going to be A1 plus A2, A3, up to AN, right? We're only considering the first n terms. Now we want to consider the same sum, but we want to reverse the order. I think there was a trick here. So we're going to say like AN plus the previous is going to be AN minus 1 plus AN minus 2 until you get all the way back to the first one, right? Off to the side, let's mention that the general term is going to be the first term plus n minus 1 times d, right? I think that's kind of right. So now let's add these two together. Let's add these two together, right? On the left, we're going to get 2 SN, and then on the right, we're going to have A1 plus AN, right? And then we're going to say plus. Now, if we have this like A2 plus AN minus 1 plus, and basically continue that pattern, and then the last one is going to be, again, A1 plus AN, right? So now, those middle terms, let's look at the A2 plus AN minus 1. Let me see. So if we consider A2, that's going to be A1 plus D, right? A2 is going to be A1 plus D, and then AN minus 1 is going to be A1 plus, I guess it's going to be what, N minus 2? Because it's going to be N minus 1 times D, right? So that means that A2 plus AN minus 1 is going to be, if we add these two together, let me see. It's going to be A1 plus D. We're going to have A1. Now, if we distribute that D, we get what? ND minus 2D. Okay. I think we're right there because D minus 2D is negative D, right? Let's see. So we get 2. We get 2A1. Let me think about this. D minus 2D. 1, let me think about it. It's going to be N minus 1 times D. Instead of doing it this way, let's back up right here. Delete, right? So if we add these together, we get 2A1. N minus 2 plus 1 ends up being what? N minus 1 times D. How do we equate that to AN? We got to show, if we show that that's AN, then we're home free. Because basically what happens is you end up with A1 plus AN each time. It occurs n times, right? Oh, that's A1 plus, okay. Oh, it's right there. We're there. It's here. So what we have here, this is A1 plus n minus 1 times D, right? We got it. That's it. So then, but then that's equal to A1 plus AN. Whew, it was irking me. It was on the tip of my tongue for like hours. I was like, what the hell? What kind of ribbons, right? So now we've shown that A2 plus AN minus 1 is just A1 plus AN, right? We can do it one more time. I think we got past the hardest part, right? Because if you continue the pattern, the next one will be what? The next one will be A3 plus AN minus 2, right? So basically, it will be the same thing. We should be able to start there and finish at A1 plus AN, right? Again, you don't have to know any of this. It's all backstory, right? Let me just do it one more time. So then A3. Now there's a more simple way to do this, but I'm just going to go with this for now. Okay, here, let me try the more simple way. A3 is going to be what? All right, let's just do the same thing. There's another way to arrive at this conclusion, but I'm going to keep with this. So then A3 is what? A1 plus plus 2D, right? A3 is A1 plus 2D, and then AN minus 2 is going to be what? A1 plus, let me see. It's going to be N minus 2 minus 1, so it's going to be N minus 3 times D, right? Then if we add these two together, then A3 plus AN minus 2 is going to be basically 2A1. Let me see, N minus 3 plus 2 is going to be what? N minus 1 times D, and then you can break it apart like we did in the previous. This is going to be A1 plus N minus 1 times D. And that second part, this is really just A1 plus AN, right? So all those middle terms are really just the first plus the last. Now, then the question becomes, well, how many of those combinations of A1 plus AN do you have? You have N of those, right? So then if we pick it back up from here, all right, let's copy. And again, you don't have to know any of this. It was just, I'm doing this for my own sake. I see the time. I'm about to let you guys go. And we're pretty much done. So again, so basically what happens is if we take this 2SN is really just A1 plus AN plus A1 plus AN plus it's basically that same thing over and over. But this occurs N times, right? So from here to here, that happens N times. So then we have 2SN equals N times A1 plus AN, and then divide both sides by 2. That sum ends up being A1 plus AN over 2 times N. And I think that's it. All right, that's what we said. And there is another way to go about it. That's just because instead of using this general term, we could have written A2 as A1 plus D, right? We could have written A3 as A2 plus D instead of using the general term. There's another way to go about it, but this suffices as well, right? I just wanted you to see that, where that formula comes from. Again, now this page, you don't have to know this page. I just was doing it for my own sake. All of this stuff you see here, you don't have to know this. This is just showing you where that formula came from. But for our purposes, again, you just need to know how to use it. It was irking me because I had seen it before, I had done it before. I was like, why can't I remember this? Let me go ahead and wrap this up. I don't want to keep it for no longer than 5 minutes. Let's just hang out for 5 more minutes and then. So find the sum of the arithmetic sequence, right? So we reiterated that the nth partial sum is going to be n times this a1 plus an over 2, right? And we're also using that our nth term is going to be a1 plus n minus 1 times d, all right? Let's see. We have our a1 and we also have d, but we don't know how many n's. Now we could count, but let's just plug in what's given. All right. So the a1 is 1. N we're trying to solve for. The common difference, it looks like we're adding 3 each time. And the nth term is 25, right? So now we can solve for n to see how many terms there are. So if we distribute the 3, okay. So then we get 3n minus 3 plus 1 equals 25. What is that, a negative 2? So then that's 27. 3n equals 27. So then n equals 9, right? So then if n is 9, so we want to find the sum of the first 9 terms. So that's going to be 9 times the first term, which is 1, the 9th term, which is 25, over 2. And I think that ends up being 117. Okay. Sorry about the other thing I was going to do. Like I said, I couldn't shake it because I know I had done it before. And I was like, wait a minute, how did that thing go? I had to think about it. Had to let it marinate and sit for a while. Okay, but we got to the bottom. And again, the way I did it, I think was a little bit more complicated. I feel like there's a slightly more simple way, a way that's a little slightly more simple. Instead of using a recursive formula, using the way I did it, there's another way. But again, you don't need to worry about that. I just wanted to show you where that came from. Right? And I think that brings us to the end, right at the time we wanted, right? Okay, so hopefully that wasn't too bad. It wasn't too discouraging. Let me think. So yeah, so we have one more section to go through before we get to exam 3. So this was section 6.2. We want to also look at section 6.3. And so next week will be section 6.3. So Friday, this week, we'll go through some homework associated with this section. Next week, we'll go ahead and do section 6.3. And then the week after that, we'll be ready for exam 3. And then we have one more lecture. It's going to be a supplemental section. It's not in our book. So I want to say the materials are available on Pearson. There's a homework section already assigned. You should be able to link to that book to kind of work that problem set and to get to have resources. So we'll work on that week after exam 3. And then we'll have about 2 weeks of open period. Now in the schedule, I intended to be reviewing for the final, which I still want to do. I want to spend most of the time reviewing for the final, but I also kind of want to see, can we take some of these concepts and apply it to something that we enjoy or something that's relevant to us. Again, it's a couple of things that are relevant to me that I feel like are a direct application would be gaming and pattern recognition, and or origami. I do origami, paper folding. Construction and measuring and, custom fits and builds and things of that nature. So, and if you have something we can explore, it doesn't have to be these things. These are things that I just enjoy doing. Another application, but we don't have a 3D printer. At least I don't have one right now. But, if you had a 3D printer, and for instance, I do ride share, Lyft and Uber and stuff like that. And I picked up this client. He said that he has a 3D printer and he was printing phone cases. And he was doing it so much, he claimed that the phone company called him and hey, will you please stop making these cases because you're taking money from us. But that's just it. That's the thing about this day and age. It's we don't need these establishments. We can actually do a lot of this stuff on our own. The whole point of a lot of these systems, they want us to be dependent on them. They want us to depend on them so that way they can hold it like the carrot over our head and tell us hey, do this or else I'm gonna take this carrot away, right? But what happens if they don't have a carrot? What if they don't have anything to dangle in front of us to control us? They don't want us to go within and empower ourselves. This is why I love math, because it's so empowering. It's you start to see the holes, you start to do for yourself, and then you don't really depend on these systems. So it's, you know, it's a lot harder to control somebody that loves themselves versus someone that's afraid of everything. Oh yeah, I'll do what you say to do because I don't want you to do what I don't want you to do. I don't, you know, I'm afraid, so I'll do whatever you say. Right? That's how they trick a lot. So, but when you abandon that fear, you know, you're a lot harder to control if at all possible, right? So anyway, that brings us to the end of this session. Again, if there aren't any burning questions, feel free to unmute yourself. But if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care. See you on Friday. Peace. This is what I was singing in the sky, just the two of us. I don't know if they're gonna like take down my video because of the song. They'd be sensitive about that kind of stuff. All right, that's enough. I'll wait. I can't get the notes. Okay, take care, guys. See sometime with you. Two of us. We can make it if we try. Just the two of us. You and I. Just the two of us.
Thank you.
Yep. Take care.
Yeah.